All right, look. It says photosynthesis is sunlight energy being absorbed by plants, and this reaction is being absorbed. So I want you to let me know whether it's endothermic or exothermic. Copy your learning target. Let's get it done. Keep on. I want you, again, look at what you write. It's hard to look up there and just write. Look down. You know, look up, look down. Look up, look down. What's up, Barry?
Are you going to be on YouTube?
No, you're not going to be on YouTube. Sorry, bro.
Why not?
We can, I guess.
Alright.
Okay. YouTube will work, so. And take a chance.
Everybody's here.
Thanks, sir. I'm glad everybody showed up today.
I'll wait for
Ooh. Just got an email. A good email.
at the job.
Where's T? Anybody in here go TJ?
Me?
Did you?
Yeah.
Where is it?
Newburgh. Why?
All right, so everybody got it?
Don't go
Writing
to
bell
TJ.
work.
Don't go to TJ.
Is somebody? No, it didn't. I'll just find her. I wouldn't
You
mind.
don't have rats in
I know
this
where it's at.
classroom.
We never did find that spider that was in there.
Oh,
Hold up.
I probably would have put my bags in. I've told y'all that before. I wouldn't have said any bags, anything on the floor. All right, let's roll. So, okay. Learning target 13. I can describe a reaction as either endothermic or exothermic reaction based on the evidence it provides, okay? So let's look at the bell work. Photosynthesis is sunlight energy being absorbed. So if it's absorbed, is it going in or is it going out?
Going out.
Okay, let's think about a sponge. When I take a sponge and run it underneath a faucet, it does what to the water? It absorbs, it soaks it up. So if it's absorbing, paper towel, we spill something and we put it over a puddle, we absorb it into the paper towel. What is it doing to the paper towel?
It's
absorbing the liquid.
It's absorbing, it's going where?
It's going inside.
So inside. So therefore, if energy's been absorbed by plants, photosynthesis will be what? Endothermic. It's going in. Okay? All right. So let me hand you this worksheet. Let's look at this. All right. I should have enough for everybody. 1, 2, 3, 4, 5, 6. But if not, what do I do with the magnets? Oh, okay. So EJ and Javante, take this set. You too. And then here's 2 sets. All right. So step 1 says, take the pair of magnets apart. What does it feel like? So go ahead and take your magnets and try to pull them apart. What does it feel like? Do y'all remember when we did, huh?
It won't.
You gotta, come on now, you gotta get a little grip to you.
But it's not.
Let me see. Let me see.
It's not.
Oh, these are double,
Yeah, they
Okay, let me see that one. Let me see the other one I gave you, EJ.
No,
Let me see, Darian. That's why, because yeah, one set, these are thick magnets. Okay. So here, I'm gonna pass these around. Everybody try to take them apart. All right, and tell me what you feel. Just make an observation, okay? So just pull them apart, pull them apart, pull them apart. Remember when we talked about bonding, right? And we said a magnet, we said a battery has to have what 2 types of ends? Just like a magnet.
A negative and a positive.
Has to have a negative and a positive, right? So what, let's see, ooh, this would be a throwback right here. What force says there's a positive and a negative end and they attract?
Say it again.
It says that we have a positive end and a negative end and those 2 attract.
A battery.
Give you a hint. No, not necessarily, don't give me an example. What force is that? I'll give you a hint. It has something to do with magnetic.
Electromagnetic?
Electromagnetic force says that it has what?
I was trying to figure that
Negative
out.
and a positive.
A negative and a positive. We know the opposites do what?
Attract.
Opposites attract, right? Okay? That's not how it is.
Look, question.
Alright, so tell me what you feel when, oh man. What did you feel when you tried to take the magnets apart, Darian?
Watch this.
What you say again?
What did you feel when you tried to take the magnets apart?
Yeah, I'm talking.
Oh, I did.
What'd you feel?
I feel the vibrating on my hand.
The vibrating on your hands? Okay, what about you, Eugene?
Force.
Force, okay, you felt energy, force, great job. So what did it feel like? We say force, what else? You say vibrating,
We didn't get a picture.
anybody else? Oh, I didn't pass this out, did I? No, my apologies. 1, 2, 3, 4, 5, 6. All right, here. All right. So, we felt force, we felt vibrating, anything else? Any other observations?
No.
All right, why is it so easy to pull them apart? Okay, well,
Turn
we
it
did.
on the other side. Turn on the other side. It's
Hold on, let's use vocab words and stuff we know. So electromagnetic force, right?
Yeah.
And we know that electromagnetic force says that what?
They come together.
What do?
Positive and negative.
Or so opposites what?
They attract.
Opposites attract. You got this, you got a pencil, don't you?
Mm-hmm.
All right, write this down. All right. So let me ask you this. As we pull the magnets apart, do we see energy in the system take them apart, or do we perceive energy as leaving? All right, so is energy going, essentially, with the magnets, do we feel like energy is coming together, or it's going apart?
Going to court.
It's going, okay, you say going apart, you say coming together, right? Naturally, they do what?
Opposites, yeah. But if it's the same, they
So if we pulling them, is energy going out or going in?
it's going out.
It's going out, right? Okay, so that, did you put energy in the system to take it apart or perceive energy leaving the system? Energy will be what? If it's going out, it will be leaving, right? Sorry. Man, fourth period was killing me on my handwriting today, man, so I'm gonna try to do better.
It says right there on the paper.
Where?
I mean, it says leaving.
Make sure I got that. Alright, so this is like bond breaking. Bond breaking is a what? If energy is leaving, then bond breaking would be what? Endo or exo?
Exo.
Exo, right? So this is an exothermic, right, process. Got it? Because again, we have the bonds breaking, because if they were getting formed, they would be what? The magnets would do what?
Come together.
They're coming together, so since they're going apart, Kevon, the bonds are what?
Breaking.
Breaking, okay? So let me make sure I get this. Alright. So then, oh, I'm sorry. I labeled that wrong. Change this, and I'll tell you why. Because it's more energy going in to the fourth one. Alright, this is I'm sorry, I apologize. In terms of the energy coming together first, in order for it to break, it first has to be what?
It has to go in.
First it's got to come together. In order for us to pull apart, first they got to be together, right?
Mm-hmm.
Alright, so when they break, it's going to be the endothermic, okay? We can still say it's leaving, alright? So, now, on our graph, what we'll have is more energy, because it's endothermic, do we have more energy coming in or more energy going out?
Going in.
Going out.
Going in. No, Darian's right. It would be more energy coming in, right? So our graph will start somewhere here, right? We're going to shoot up, right? But where do I stop? Tell me when.
Right there.
About right here, right?
Yeah.
All right. Now, let's talk about it. In labeling our graph, right? We've said before that the energy on the left is called the what? Product or the reactant?
Oh, that's the product, and the other side's reaction.
Okay, are you sure?
No.
What
That's
comes-
reacting.
What do we, okay, it's like we got a recipe, right? Let's think if we have a recipe. And it calls for 2 eggs, 5 pounds of flour. Those would all be the what?
Ingredient.
The ingredients for the what that we're making.
Cake.
The cake or whatever, or we would call this voila, it's my what? Final what?
Recipe.
Nope,
Can't put as the what?
product. It's my final product. So in order for us to have that, we have to make it first, right? So again, in thinking of that, the product will go where? At the beginning or the end?
And
At the end, on the right. Great job. So we'll still label this as our product, okay? We'll call this our what?
Yeah.
Reactant, okay? And as we do that, now, what goes in the middle? Do you remember? Because let's talk about this for a second. Every reaction will naturally happen, right? All right, we can speed up the reaction by adding a what?
Catalyst.
We can add a catalyst. All right, but it's still, because because it will react, we'll have a what?
A reactant.
Nope, think about this. Where's my phone? I don't have it. Here's my phone. Boom, I got my phone out, right? My phone don't work. I just got it. It's brand new. I need to call T-Mobile and get it
Reactivated.
activated, okay? Alright, so the activation energy will be here, guys. And it is the amount of energy required to what? Create a what?
Catalyst.
Not a catalyst. What's this whole thing?
Oh, a reaction progress.
Or reaction. Okay, so let's write that definition. We can just do AE right here. Alright?
Yeah.
And what did I say? Amount of energy. Can y'all read that?
Yeah.
Well, I'll read it out loud. Amount of energy required
What'd you say?
to have a what? Keep on.
What?
To have a what?
Catalyst.
Not a catalyst. No.
Product.
No. A reaction. Alright, pay attention. It's free. Alright.
What's the
Moment.
question?
So the activation energy would be here, right?
I can't, what's the
Oh,
question?
here? The amount of energy required to have a reaction. Sorry. I'll say it again. The amount of energy required to have a reaction. Alright, good job. So in the endothermic reaction, we have more energy coming in or more energy going out.
Coming in.
Alright, take those two magnets, Jamie, and try to put them together, but I want you to flip them.
Where is the man? I need that.
Here.
So, we have, nice catch. We have, what happens when you try to, I want you the same size, what happens?
Force.
The
It
force
pushes
what?
Against it.
Do you remember what kind of force that is? Well, the
Uh,
only one that's strong enough to make two like forces come together.
it's called gravitation.
Gravitational force, great job. It's like a big, huge bear hug, right? And we said in the gravitational force, we said generally two positive ends want what?
Come together.
They want to attract, right?
Right.
Okay, great job. That was like September, man. Real talk for y'all to remember, that was pretty good.
Y'all
Really
done this in
good.
September?
You did it in September as well.
You missed
No,
that.
not that. We're talking about the magnets and the energy.
Yeah.
Yeah, in Miss H's class. All right, so let's look down here then. All right, so let go of the magnets and let them pull each other back. So, try the magnets.
Like
Pull,
this?
sit one down like you did, yeah. See what happens.
It gonna move.
Like this.
Like this.
Flip
No,
it over
no, put them
the
on.
other
Put them
side.
on positive, negative side.
Oh my God, it's gonna hurt.
All right, so what are they gonna do?
He said it's
What are they doing?
Okay.
Let me see it so I can give it a go. No, you got
Oh
one
my
on
God. Oh my God.
All right.
Eugene.
So what happens?
Comes together.
Why?
It's a positive and negative.
Oh, I see what you're saying. Because it's got that.
Yeah.
That's because it's doing what then?
It's,
It's attracting, right? So we got a positive end and a negative end. Opposites do what?
Comes
Right.
together.
All right. So we have a force. We have energy when we pull them apart. We have the bonds breaking. But when they go together, they're what?
That's right.
They attract or they what? They come together. Not force.
Gravitational force.
Nope.
Or
It has nothing to do with the gravitational electromagnetic.
Pulling each other together.
Their bonds are being broken
they're endothermic.
in endothermic. Then what have they been doing here? Look at it. This is like bond.
XL.
But I know we know it's exo. But what did read the paper? What does it say? They're what?
Pulling each other back.
Gentlemen, this is like bond
forming.
forming. The bonds are coming together, so they're being what? Formed, right? Okay, what if I said line up and form a line? Or excuse me, stand up and form a line. That means what?
Line up.
Get in a line, all right? Stand up and form a V. Make a V, right? Well, but that's what I'm saying, right? Formations. Let's think about football. We do formations every day of practice. Formations is what?
Play.
The play, the offense versus the defense. What does it look like? Okay? So bonds are being formed or come together. Okay? So, what did it feel like? Pass it to Darian.
What is the hurt doing?
Alright, so what does it feel like?
Let me see.
Based off of that. Tell me put them together. Tell me what it feels like. Kevon, you tried it. What did it feel like?
Let me see.
They came together.
It was like I was like this. It just come right down.
Okay, so what does it feel like when something comes together? Could you
Vibrating.
vibration? Thank you. Alright, what else?
Forming. No.
They came to did they well, let's use come together.
Yeah, they
We can say
attracted.
form. Okay, ooh, I like that. We use that word. Good job.
What do you say?
Attracted. Alright. Man, that breeze feels good.
No, no.
It's too cold.
That's why I told you it was water.
Alright. So is the energy leaving the system or going into the system?
Going into.
It's going into, right?
Right.
Going into. Alright. So, you with me? Let me get those magnets. Just make sure you ain't. We're good on the magnets.
Make sure I ain't stealing them.
Nah, you can say y'all still. Alright. Thank you.
Decorations go in the refrigerator.
Put me.
Oh, man.
Hey, you should put it next time you get a test, man. You take your magnet and put it on the refrigerator. Y'all never do that?
No,
I
bro.
did.
You do? I
To
would.
see how good I can do next time.
No,
It's a
mom
reminder.
She just put them in like a folder file.
Alright, well, man, put them somewhere where you can visually see it, right? Same difference as your goals. Like, anybody here got goals?
Yeah.
Yeah.
Well, give me one. Give me one of your goals, EJ.
Tell me
Go to
about
college. D1.
Okay, so maybe you should write it down. Because I was always told a goal is only a wish unless you write it down. So in my house, if you walk in my house, you be like, Coach, you crazy. I got like goals on the back of my bedroom door, goals on my mirror in my bathroom, goals on the back of the door as you going out the door. Why? What does it do for me?
It makes you have higher expectations.
Did you go to the NFL?
No, I didn't. That's like the 6th time you've asked me that. So you got to do a better job of paying attention to ask the same questions.
Why are you forgetting?
Well, it's because you don't listen, because you got 2 ears and 1 mouth, but that mouth runs twice as much as the mirrors do. Listen to me.
I never asked you.
Put your goals. Alright, put your goals right here. So I'm walking out the door in the morning, right? And I'm looking at my goals and it serves as a what?
Reminder.
A reminder, right? It serves as a reminder. So I know what I'm about, right? So when I come in here and I come to work, somebody might say something, I'm like, alright, my goal is to just keep it cool today. Right?
Right.
That's that you okay? And it helps you hold yourself accountable. Because if you don't hold yourself accountable with somebody else,
No.
No.
not at all. Alright. Alright, so this is like back to it, my bad, that was a message of the day. Message! Alright, this is like bond forming. Bond forming is a
Exothermic.
exothermic. Alright?
Alright.
Great job.
Good job, boy. Good job, bro.
Alright. So in this case then, are we gonna have more energy going in or more energy going out?
Going out.
We're gonna have more energy going out. Great job. So then my graph will still look like
What would it look like?
it'll be right here. But we're gonna bring it down now, right?
Yeah.
Looks like a alright.
Yeah, Yogi.
Looks like a what?
Said like yeah, Yogi.
Nah, what'd you say? For real.
I said Yogi.
Alright.
I thought you said
So man.
Got him.
Alright, got him. Got him. Alright, so on the left side will be what then? I have to think of my recipe. Think of my recipe. What will come on the left, Javante? If I'm gonna label the graph.
React.
My reactant, alright. Then what will be on the right, Darian?
Product.
My product, alright. Kevon, for $1 million. Alright. What goes in the middle and is necessary in order to create any reaction? What is necessary for us to have any reaction? We have to have a what?
Exothermic.
Nope. I want you to use the one on the bottom, use the one on the top to help us label the one on the bottom. So what are we missing on the graph on the bottom that we have on the graph on the top?
Product.
No, we have a product, we have a reactant. Use your graph.
Look at this, sir.
What is it? You can't read it. Why? Because you wasn't paying attention when you wrote it, so you can't even read your own handwriting.
Yeah, it's product.
What is this? We have a product, we have a reactant, we have a reactant, we have a product, so what would that be? Darian, what is it?
I think it is electromagnetic force.
What, not right here?
Yeah.
Nope. I didn't write this all the way out.
This Friday.
So then what would it be?
This Friday.
The amount of energy required to have a reaction. In order for us to have an exothermic reaction or endothermic reaction, we must have what?
Activation energy.
Okay. So keep on. In order for us to have an endothermic reaction or an exothermic reaction, we must have what?
Activation.
Okay. So that would be where then?
Bottom.
Where, here?
No.
Where?
Top.
Here. Right? Alright, so then we want to draw this here, and I'll label it AE. That's what you said earlier, Darian, but I didn't put the name. So AE, activation energy, right? Okay, so naturally we said that every reaction will go through, right?
Right.
Okay? But, okay, well let me say that again, let me preface that again. Is it necessary for a male? No.
Big right.
Is it necessary for a reaction to have activation energy?
Yes.
Must a reaction have activation energy?
Yes.
Why?
Because it ain't gonna work.
It won't what?
What?
Not necessarily work, or it won't what?
Well,
It won't what? But hey, he's answering questions while y'all laughing.
it won't activate.
Not necessarily activate, but okay, if I mix,
It won't
let's say I
react.
got 2 hydrogens and 1 oxygen and I put them together.
Yeah.
If it doesn't have activation energy, I won't get what?
No reaction.
Water.
No reaction, therefore I'll never have water, right?
Right.
So remember the elephant toothpaste, right? Okay, so let me ask you this, then how do we speed the reaction up?
We put more.
We put a catalyst to it.
We add a catalyst to it, right?
Yeah.
Okay, you with me,
Is that
Darian?
even real?
Okay, huh?
This ain't real.
Yeah, it's real. A catalyst. It's no different than we talked about growing fertilizer. For example, I got lawn care business, right?
Yeah.
I got some yards who over the spring, over the summer, over the fall, they get treated. So people show up, there's another company, they show up and they spread like grass seed on it, they spread fertilizer, it keeps the weeds out. Well, when I go to mow them every week, them yards are usually like this high, as opposed to the ones who don't are usually about this high. Why?
Because you put
They have a fertilizer,
Yeah.
but the fertilizer serves as a what?
Catalyst.
A catalyst. It makes the grass grow what?
Fast.
Fast.
Faster, more thick, more
It speeds
pure,
up the
right?
acceleration.
It speeds it up, right? Naturally, the grass will grow either way, right? It's gonna grow. Activation energy, photosynthesis is absorbing the light. It's going to grow. But if we add the fertilizer, we add the pesticides, we add a what? Catalyst, and the catalyst does what?
Speeds up.
Speeds up the reaction. You alright over there?
Yeah, I'm sure.
Okay, you look like you spilled some water on
You got a
yourself.
ride lawnmower?
Yeah. Alright, good job on that. Alright, I'm gonna put a side note down here on the bottom, okay? And just put to speed up reaction, we add a what?
Catalyst.
To speed
Caddy.
up reaction,
I got a caddy.
we add a
What time did you
catalyst.
get home, Coach Morton?
Man, I was in traffic all night Saturday.
It was an hour long.
Yeah, and then I had to go pick my nephew up. He spent the night with me Saturday night, so.
You should have put back. What's that place called where they do newspaper?
I got home at
That's how
11
we got
o'clock.
out.
You got out.
I got him like
Yeah.
1.
I
Yeah.
got home at 11.
Yeah,
Because I'm stressing. I live right down the street from them.
Yeah, I had to walk from, I was at where I saw you, I was at the Humana building, and I walked
Yeah.
to 5th and Chestnut. And then I took me, my cousin lives on 4th and York, and we go from 5th and Chestnut to 4th and York, took me 35 minutes.
I took
And
a
it's 2
picture.
blocks.
I took a picture of that helicopter.
Yeah.
I was right by it.
What, was a helicopter on the ground?
Yeah, the military helicopter.
Oh, yeah.
I had to take a picture. My mom, I was like, "Mama, hold the camera," and she was like, "Come on, boy, we ain't got time for this." It's like, "Nah, we got a little time for this."
Oh, you got a picture? Like I said, I mean, it's cool that you got your cell
That
phone
was-
out in class,
They
but.
was smoking blacks up the tour.
I just had
Nice.
to.
Let me see.
Alright, so let's keep going. Alright, so let's look at this. Alright, so again, just review. Hey, put that up. We'll look at it here at the end. Let's do this back and we'll do the exit and we'll be done, okay? Alright, so again, if bonds are breaking, what kind of reaction is that?
Catalyst.
That's dope. and-
Listen to me. Listen to me. No, it's not funny because I've dealt with this all day. You have the resource, right?
Yeah.
Alright, so let me ask you this. Everybody here know how to read, right?
Yeah.
So you can learn anything in the world that you want. You don't have to guess. You can learn it, right? Because you can what?
Read it.
Read. So again,
Research.
Kevon, when bonds are being broke, what kind of reaction is that? Come up here.
Endothermic.
Come up here. Point to it.
Start there.
Come up here and point to it. Read that. Read it.
Endothermic.
Read the paragraph.
This,
Yes. Stop touching the board because I'm on the mark. That's all good.
this is like a barn breaking is in endothermic.
Alright, so endothermic reaction, does it have more energy going in or more energy going out? Are you sure?
I know envy does like you said something water.
Is energy's being what?
Absorb.
Absorbed. Okay. So then, EJ, when bonds are being formed, it's what?
Endothermic. I mean, exothermic.
Why so?
Because they release it.
Well, bonds are being formed. They're coming to what?
Together.
Together. All right. Now, let me ask you this: in the exothermic reaction, do we have more energy going out or more energy going in?
Running.
Going in.
Are you
It's coming
sure?
out. You said.
Oh, it's a
exo.
50-50 chance. But what you said? I said exo, which means what?
It's going out.
That's the exit, right?
Yeah.
We're going to go out the exit. So it's going to be what? Is it going to be absorbed or released?
Release.
Released. Okay, let's look at this. Alright, so again, 2 solutions. So here's the first one. 2 solutions increase in temperature when mixed. Is energy absorbed? Alright. The temperature did what?
The temperature rise.
Increase, right? So the energy was what? Released. And if the energy is released, that's what? What kind of reaction?
It's an
Exo,
exo.
Devontae.
Exo.
Exo. And then bonds are what?
Form.
Form. Alright, let's look at number 2. Molten lava turning black into, back into rock. Alright, so was it temperature? Is it going up? Is it going down?
Which one?
It's going down, right? So is it being absorbed or released?
Release.
Think about it.
No, it's absorbed.
Why?
Because,
It's going out. It's releasing.
But absorb means to come into.
Oh.
Release means to go out. But think about it.
it's
Molten lava is turning back into rock. So let's think of a
It's
volcano.
absorbing.
It blows up, right? And then the lava does what?
It gets
It
hard.
comes
It
down.
gets hard as it does what?
It comes down.
Slows down.
As it slows down. What as far as temperature? Think in terms of
It
temperature.
cools down.
As it cools down, so the bonds are being
Usually
what?
when it hits water, it's
So-
being absorbed.
Absorbed. So if it's absorbed, it's what?
It's endo.
It's endo, and therefore the bonds are what? Formed or broken.
Broken.
All right. That's what I want. Let's take 5 minutes. I want you to try your best on this. All right, and then we'll go over. Okay.
Yes, sir.
Any questions? All right, come on, Kimon, you got it. Yeah, have it for the time on. All right, what's say 5 minutes? All right, so water is boiling on the stove, right? Temperature's doing what? All right, well, no, not necessarily a reaction, but the water is boiling on the stove. So the water's sitting on the stove, right? All right, and what's it doing? Is it getting hot or is it getting cold?
go.
It's
getting
hot.
It's getting hot, right? Okay, so what is it doing with the energy? Is the pan absorbing the energy or is it releasing the energy? You sure? Well, don't guess, think about why. If we go home and I say, let's make some noodles, right? And you're gonna put some water on the stove, you can cut the stove on, right? In order for that cold water, because naturally you don't just pour the water cold into the pot, do you? So that cold water has to get what? It has to absorb the what? Not the water. It's boiling, so it has to absorb the what? The heat from the stove, right? So if it's absorbed, then it's what? Keep on. Let's go. Eugene, you good?
Yeah.
All right. Hey, look, everybody got a pencil, right? Try it. Guess what happens if you're wrong?
Race.
You can always erase it, okay? All right?
I was
So
feeling
just-
I'm gonna do quite
So if
fine.
it absorbs, it'd be similar to this one, then it would be endo, right? And the bonds would be what? There you go.
Yes.
You just did that one. Use this one. So what do we do here? There you go. Oh, it smells like feet in here, boy.
Not me.
You want?
It's not me.
Alright. Well, let me ask you this. Magnet's been pulled apart,
Both
right?
of them.
Hey, guys, nobody should miss the fourth one. Why?
Because we just went over.
We just went over. So bonds what? That's wrong.
This
Pulled
one?
apart. Magnet's been pulled apart. Because that's the top one. It would be,
Oh, I didn't even put the.
okay?
I looked at it
So
wrong.
think about it. So magnet's been pulled apart is what? Not, no, because that's not one.
Oh,
What is it? Alright, so then what kind of reaction is it?
No, I really didn't look at it.
Bonds are being what?
Yeah. Boy. That's what I said.
Alright, number 5 says 2 aqueous solutions are at 25 degrees Celsius change in temperature to 33 degrees Celsius after being mixed. Hey, listen to me. Number 5, this one right here. I just said 2 water solutions at the 25 degrees Celsius change in temperature to 33. So the temperature go up or down?
Yeah.
Yeah.
25 to 33. It's 25 degrees today, folks. It's 33 degrees tomorrow. It'll be a little bit what? Warmer. So what is it?
Hey.
So the temperature, so therefore it's doing what? After they being mixed, it's being what?
Yeah. Release.
Well, you tell me, stop guessing. Think about it.
It's real.
absorb.
The energy's being what? Absorbed or released?
Absorbed.
Alright, so make it happen.
Endo. B.
Alright.
Absorbed.
So then the bonds will be what? Yeah, so then it'll be
got you.
absorbed. So if it's absorbed, what's it gonna be? Endo or exo? Look at your notes.
Endo.
Hey, look, it's easy to guess when you got a 50-50 chance. If you guess something and I say, well, look at your notes, it's got to be obviously the other answer. I don't care that you guess. I don't want you guessing. I want you to have a justified reason as to why you came up with your answer. Does that make sense? That's kind of like you asking mom, can I go such and such's house? And they go, what?
No.
Nah.
No, she says why, and you got to say, you got to explain as to y'all have a good weekend planned, and y'all want to, you understand what I'm saying?
Yeah.
If you go, well, can I go to Kevon's house? And she goes, why? And you go, I don't know. She's going to say what?
No.
No, you ain't got no business over there. All
Nah,
right?
we just want to play basketball.
Let's go.
We're gonna make some chemistry.
Well, let's look at it. No, it can't be. Not the third column. Why not?
Kill
All right, come on. Where you at? So an egg is cooked in a hot pan. All right. So the energy. Well, think about it.
20, no, I did not take
The egg has to do what? It has to get hot. So where's it getting the heat from?
I'll be like that. Come on, get it, keep on.
Come on. Come on. Finish that. Let's go. We got.
And I'll be like that.
2 minutes.
Yo, we got like 1 minute, but I'm gonna add another minute.
For
We had
real.
about 4 more minutes.
I'm almost done.
That's why I'm almost gonna count some what. I'll give you 3 more minutes. If it's absorbed endo, so if it's endo, bonds are what? Bonds are breaking. So you better form. Alright?
Alright.
That's okay if you mess up, yes.
Look. Open up the photos, Jamie. It's okay.
Get that done. You still got, I mean, at the end of the day, we got a quiz over this. Come on, keep
Over
on.
this?
Yeah.
Tomorrow.
Oh yeah, we missed our test.
Because y'all wasn't here Friday. We didn't have it.
I thought we did take the cruise. Me, you.
Thought we was here
No.
Friday.
You were.
You the only one here?
Nah.
Alright, come on, guys. Hey, look, I gave you extra time not to talk. Let's go.
Oh,
Yeah.
yeah, here, boy.
EJ, Javante,
Oh, others.
let's go, guys.
See, bro, I don't even got him in my photo.
Jamie.
Cesar, right?
Yep. Because, alright, what are my 5 senses?
It's touch, smell, hear, and feel.
Taste, touch, smell, hear, and feel, right? Alright, so that's an example of reaction, though, right? Energy being what?
Being absorbed.
Is it?
Sound
If something goes boom 3 blocks away and I hear it,
oh, that's release.
there you go.
So when they were releasing the fireworks,
Okay, fireworks exploding is energy being,
release.
there you go.
Hey, how did they light them up? Off of?
Man, they set the bridge up something nice. They said it costs like $10 million to do that. So potassium is dropped in water causing an explosion. Is an explosion a sense? Can you hear it?
So they was.
Okay, so then the energy of this is being what?
With the waterfall.
That was good.
The gel
Potassium is dropped. Guys, I'm gonna tell you something. Hey, camera's on and that's cool. But I've asked y'all 3 times to get this done. And I know good and well, y'all know I don't like repeating myself.
All right.
Get it done. Stop talking. So if you hear the explosion, is that one of your 5 senses? That's energy being what? No different than a firework. It's an explosion. So it will be what? Released or absorbed? Released. If there's released, then it's what? Exo and bonds are what? There you go. Alright? Same thing with you. Let's look at this one. So this one, okay, released. So if it's released, is it endo or exo? Alright, exo and the bonds are broken or formed. Okay?
That's my
Alright.
I almost got it done. I need 3 more.
Jamie, come up here and fill in something.
Can I go up there and do something?
Yep, everybody's got 2. Pick 2.
Oh, the first 2.
Nah,
Don't matter. I don't care. First come, first serve. Don't try to do the first 2, Kiwan, just because that's the only ones you got done.
No, I'm not.
I don't know how to cut my phone. I see. Thank you, sir.
Nah, he picked up the marker.
Come on, man. All right. Yeah, he's burning daylight.
Hurry up, Yandy.
Make some more.
Yes, sir.
This is right.
No, this would actually be an option because the heat has to exit in the pan, right? We gotta cut the stove on so the heat's being what? Released to absorb. There you go. Why you take your shoes off? Cause you seen Jamie take his off?
Well, I've been in here, man's
Who's a
off.
boy?
I mean, I've been in here, man's off.
You had who's off?
Mine.
He said mines.
I'm for real. That's
Okay,
why I'm
come on. That's fine. Pick two more. Come on, Javante. Come on, EJ.
What are you doing? Work.
What you need to do?
Can you reach in the desk and grab me a referral, please? Mr. Mark, you grab one out top of the desk, please. Good job. There's one in there. It's okay. I'll get one. Eugene, come on. Come on, EJ. Let's go there. Erase that, Eugene. I don't know what that says. Not that, the E or whatever you're writing. Come on. I wouldn't copy them just yet. What if they right? What if they wrong? You don't know. I mean, if you try them yourself, yeah. But,
I did this for myself.
okay. I got you.
Do it.
What are you rushing, bro?
Hey.
Yeah, we're on camera.
Do that one. Potassium is dropped in water, causing an explosion. Is that one of our five senses, Eugene? Can we hear the explosion? We can't hear the explosion. So if there was a bomb 3 blocks away, we wouldn't be able to hear it. You can't hear fireworks downtown. So hold on, freeze. So is energy, are we hearing the energy, right? So that energy, is that energy being released? The sound, right? Is that energy being released or absorbed? No. It's released. It's releasing from what?
You gotta wipe that.
Listen, right? That's energy being released from my what?
His hand.
My hands, all right?
Yeah, brother. But I don't need to talk about you.
Great job. Great job. All right, come on, Darian. You got the last one.
Which one, this?
No, not you, Darian. Just pick one. Pick one of those two.
EJ, you only got.
So, if Darian, a volcano erupts. What does it sound like when a volcano erupts? Boom, right? So, is that sound?
Yeah.
Do we hear that? That's energy being what, absorbed or released?
Absorb.
You think so?
No, release.
Well, why?
It matters. Sound.
Because of the sound. It's one of our 5 senses, right? All right. So, if it's released, then is that exothermic or endothermic? Show me. So if it's exothermic, our bond's being broken or formed?
No.
Okay. Good job. All right, EJ, finish it out. Let's go.
Let's go, Tom, man.
PJ. Here, you tell me. Good job. What is it? XO? An injured basketball player shakes a cold pack to activate it.
It's releasing energy.
Okay. XO.
I think so.
So then the bonds are what?
Broken.
Broken. All right, let's look at this one. Sodium and chloride combine in an explosive reaction to form table salt.
Release.
Why?
Because
Give me.
it's exploding.
Great job. So it's what?
It's XO.
All right. So are the bonds broken or formed?
Broken.
All right. Let's look at it. Let's run back. All right. Here we go. Magnets been pulled apart. They're absorbed. So endo. Who did that one?
Jamie.
Bonds are formed. Great job. All right. Two aqueous solutions. 25 degrees Celsius. Change in temperature. 33 degrees. All right. So the temperature goes up. It's been absorbed. It's endo. The bonds are what? Broken. All right. An egg is cooked in a hot pan, right? So if I take an egg, crack it in a pan, well, it's got to be cooked. It's got to get hot from the what?
The water.
The water or the what? The pan has to get hot from the stove, right? So the energy is being absorbed into the pan from the stove, right?
Endo.
So it's endo. Potassium is dropped in water, causing an explosion.
XO. It's releasing energy.
It's releasing energy. How'd you know?
It's exploding.
We have our five sounds. I mean, not our five sounds. Our five senses, right? Taste, touch, hear, smell, see, right? All right. A solid metal is dropped into hydrogen chlorine and a popping sound is produced. What we got there, Darian?
Huh?
A solid metal is dropped in HCl and a popping sound is produced. Release, because we can what?
Clap.
No, not we can clap. We can what? We can hear it, right? It's been released, all right? XO formed, bonds are formed. A cold water bottle sweats when placed in sunlight.
That would be release.
Why so?
Because it's releasing energy.
That water release.
Because when the evaporation on the side of the water bottle.
Okay, but is that energy released or what? I'm gonna say it's absorbed, and here's my reason why. It sweats, right? Where's it getting its energy from to sweat?
The temperature.
The sun. So first it has to absorb the what?
The heat.
The heat. All right. So it'd be endo, and then the bonds therefore would be what?
It'd be
Formed. Okay. All right. A volcano erupts. We release. We hear sound. Releases. It's XO. Bonds are broken. Gasoline is burned in your car. I said, who did that one?
Maybe.
That's a tricky one. Let's think about it. I put gas in my car to go places, right?
It's activating, so
Not activating, but what happens as the gas is going?
it's burning
All right. Where does it go?
in the car.
Where does it go as it burns in the car?
Oh, it goes out the exhaust
It goes out the exhaust and where?
in the earth.
If it's going out the exhaust, is it entering or exiting?
It's exiting.
So therefore, it would be what?
XO.
XO. So then the energy's being what?
Release.
Released. Somebody did it. You just so it'd be
I
XO.
did that.
Okay, you did the backwards. You did it backwards though. You put form. Did you? Or did I just make it up?
You made that up.
All right. So all right, here we go. Everybody got it? Okay. So here's your exit. All right.
Are you going to track for derby?
Good job, bro.
Oh,
Good job today, y'all.
good
Hold on.
job, y'all. Good job, ladies.
Thank you, man.
All right, here we go. Simple question. I need a reason as to why, and I'll come around and check it. All right. Is it possible for a reaction to have no activation energy? Tell me yes or no, and tell me why. Okay. So on your exit slip, let's go. Some of y'all, why don't y'all have anything for your bell work? Some of y'all don't have anything for your bell work. I don't know why.
That sucks.
You should have. The bell work was endothermic, but you should have had that. All right. Tell me again. For the exit, is it possible for a reaction to have no activation energy? And tell me why. So you're going to tell me either yes or no, and you're going to tell me why. All right? Again, is it possible for a reaction to have no activation energy? Right?
Check it.
Yeah, I'm coming around to check it.
Here.
Yes.
Let me see. The answer, the first part's right, but the second part is an explanation as to why. What are you doing? Okay, do your exit. We got like 1 minute, guys. So I need you. Keep on. Don't copy his and just put. What are you talking about? Well, I seen you change your answer, but I need you to explain to me why.
No,
So
first
explain
I
why.
had yes, do it.
That's fine. Switch it, but you gotta make sure you're accurate as to why. Use your notes. Hey. Think about this. Think about the grass. The grass is naturally gonna what?
Oh, you need the
Nope, it doesn't necessarily have to have
you
one.
need the Okay, I know.
There you go.
Is
All
it?
right. That's correct. Eugene got it. No, that's incorrect.
I'm gonna use this.
Nope, it's too detailed. It's a simple answer, guys. It really is. It's a simple answer. Think about it. Can this happen without this?
Product.
Can it happen without that?
No.
No. It cannot happen without the activation energy. But why?
Because it must have,
It needs that
because it must have a
product.
reaction to form activation.
It has to have, naturally it's going to do what anyway? Naturally,
It's
without a
gonna
catalyst,
grow,
it's going
but-
what?
It's
It's
gonna
gonna
grow,
grow,
but
but it's gonna be
slow.
longer.
It's going to react, okay? It's going to react. All right, so is it possible for a reaction to have no activation energy? No, it will have activation energy, but what? It'll just be what? The reacting will be what?
Product.
No, the reaction
Slow.
will be slow. All right? No, I just answered that. No.
It says
So, no.
It's no
Right
because
here.
it takes it's too slow.
I got it down.
It's no because it's too slow.
The reaction. Listen again. Let's say it again because I feel like I failed y'all on this one. No. Is it possible for a reaction to have no activation energy? No. It has to. In order for it to have a what?
Reaction.
That's it.
No, because it will react.
But you didn't write. You didn't write in a complete sentence. I can't read your mind if you don't write a complete sentence.
No, because it must have a reaction.
I'll take that, Darian. Put your name on your work, daily work. All right. All right. Good job. I'll take that. All right. Just to run down. Tomorrow we're gonna go over this. We're gonna have a quiz of our endo-exos, okay, and our ions. All right. And let me make no. Let me check you off before you go. All right. I don't care if I had to help you with it, as long as you wrote the right thing. Good job, Eugene.
No,
Thank you.
Oh, what's up?
Let me ask you this, all jokes aside. Like, are you proud to turn this in as far as the